All right, so I'm recording now. Well, welcome to Math 2305, Discrete Mathematical Structures. I am your instructor. My name is Dr. Randy Davila, and nice to meet all of you. For a lot of you, it's probably your first time seeing me, especially if you're a CS major. Well, actually for all of you and the data science majors. This is a early course in the development of your degrees, both data science and CS. And it's a mathematics course that will be a little bit different from the mathematics courses you've had in the past. And by that, I mean, we're really going to talk a lot about logic. We're going to do a little bit of programming, even though that's not in the current syllabus, which I'll update later this evening. And I'll talk about more later in lecture. We will look at logical arguments for why things are true, not just calculating things. In fact, we will not really be calculating anything. We will mainly be focusing on arguing why something is true or false. And then we'll also be designing algorithms. All right. So it's going to be a little bit different. And I will record a video for you guys explaining why discrete mathematics is different and how it relates to your majors. I'll post this on my YouTube video and send it to all of you guys so you can watch this on your own time. For now, though, I'd like to tell you a little bit about myself because a lot of you have first time you've seen me. My PhD is in mathematics, but my title and my role at U of H downtown is assistant professor of data science. I was the first data science professor at UHD that was hired to help the statisticians and the mathematicians, which I would call myself a mathematician, but I'm starting to feel more like a data scientist as the years go on. I spend a lot of time programming, probably more so than some CS professors, and it's a big part of what I do and what I like to do. So even though it looks like more than half of you in here are CS majors, I still like to reach out to you guys and to work on projects every once in a while. I've worked with plenty of CS majors in the past on data-related projects involving programming. The two main languages that I use are Python and Julia. You'll know what those are by the end of the semester because I'm going to teach all of you a little bit of Python throughout the semester. But related to UHD, I am alumni. I graduated UHD back in 2012. I was the first person in my family to go to college and finish a four-year degree. And UHD really did change my life going to UHD. I started at university at U of H main campus and it was way too big. I wasn't used to it. I didn't know who to ask for help. No one in my family went to college. It was expensive. It was a mess. And I ended up like failing out of U of H main campus on it. Like I did. I failed two courses and I was put on academic suspension and I had to leave. But then after that, I saw that UHD had open enrollment and decided to enroll at UHD in their applied math major, which they don't have anymore, but back then they did. And it really did change me. The classes are smaller. The professors are a little bit more personal, a lot more personal, actually. You can stop by professors' offices whenever you want. Some of them are more kind to that than others, but I would say the majority of us are pretty happy to have a student stop by and ask us questions and ask to work on things or just ask for guidance. In the past, I've talked with a lot of students at UHD that might be struggling or first-time college students or all sorts of things, or want to go to grad school, want to find jobs. And I've talked to CS majors, data science majors, all of them. And I feel like I got the same type of respect and feedback from my professors when I was at UHD. In fact, some of you will probably be taking courses with people that I took courses with. So some of my old professors are my colleagues now. And I did struggle for various reasons throughout my undergrad, but still because of the support at UHD, I was able to make it through. And actually, I did pretty well at the end. And I graduated. I did research. I had actually co-authored a publication by the time I graduated, and was able to go to Rice for a master's degree in computational and applied math. And then from there, I decided to work with an advisor at the University of Johannesburg in South Africa to finish my PhD. So I have a soft spot in me for being at UHD again, and being in the position that I'm at, because my professors at UHD really did help me get to where I needed to be. And it's really cool to see students at UHD go on to do the same things. I have students that have gone on to work at national labs that have helped out with their resumes and helped out with learning how to program and things like this. One of my students is, I just found out, in a PhD program at Rice, which I helped with that a little bit. And I just would like to put it out there that I'm more than willing and open to help all of you in this class, and then throughout your journey while you're at UHD, and even after. I still have students talk to me after they graduated. So I just like to let y'all know, because sometimes, especially for those of you that might be new to a university setting, it might seem difficult to ask for help. And that was one of my problems. I didn't know when to ask for help. And then maybe some of you have experienced this in the past, but sometimes you run into some grumpy old professor and they don't know how to like talk to you like a normal person, and they're too busy doing their own thing. So it can be intimidating to ask for help, but it's not the case always, especially at UHD, considering we're such a small university. Even though we're big, like there's a ton of students that go to UHD, it still feels like a small university compared to going to a big campus like U of H main campus or Texas State or UT or A&M. It still feels small, right? So that's important for me to say, and I say it to all my discrete math students. I typically teach this course once a semester. Sometimes I have 2 sections, sometimes I have 3 sections of it, and I've taught it since 2017. And I taught it at Texas State University and at UHD. So I'm used to you computer science people. And I enjoy having you as students. And the data science people in here, you will see me a lot, so get used to me. Okay, so this course, if I can share my screen, I have to briefly say things about, I need to update the syllabus. This is kind of the standard template syllabus here. So in the learning objectives, these are all valid. Everything that you see here, logic, set theory, functions, counting, number theory, graph theory, these are all valid. Homework is going to be 50%. So you'll spend a lot of your time working with these Zybook textbooks, which I requested one the other day. I'm still waiting on the textbook to appear. Once I get that login information, I'll send it to you. It's pretty cheap. It's like $40-something, I think. Not too bad. Very interactive. Students tend to like it. I ask every semester to make sure they like it. The majority of students like it, and the majority of students learn from it. So I think that you'll enjoy that aspect, especially since if you just stay on top of the homework, that's 50% of your grade knocked out right there. Tests, we'll probably just have one exam, to be honest. That's kind of the way that it's been working since we've all had to deal with COVID and people missing and struggling with other things like financial stability with like jobs, and it's just been a mess. So I think we'll end up having one exam. And then the final project will be a programming project. This project will be written in Python. And regardless if you've ever programmed in your life, I will teach you the basics of how to work with Python and walk you through implementing this final project. To be specific, this final project uses the Python programming language to implement an algorithm from the last section of our topics, graph theory. So we implement an algorithm that solves this famous problem called the minimum spanning tree problem. And if you do it correctly, you have it as something that you can present on your resume when you go to apply to jobs when you graduate. So it's actually really useful. And if you pay attention to all the links that I put out, all the videos I send out, and you really try to learn not only the mathematics, but you try your hardest to learn the programming aspect of what I teach, this will be a really beneficial thing for you. And I've had students for years tell me that this was useful when they went on to maybe find internships or even jobs. Okay, now the Zybook will be specific to your homework, and I will not even open this book really. All of my course notes will come from this 7th edition of this book, which if you look under course content, you'll see a link to that exact edition. So if you want to know where I'm getting my notes from, just click on that link and it will pop up. And here it is, the entire book. So you don't have to worry about buying it, but if you want to, the 7th edition is pretty old now. So I would buy it. Like it shouldn't be too expensive. And for computer science majors in particular, it's kind of a must-have. It's like a classic book that you see in professors' offices, regardless of the university that they're at. Okay. Also, I plan on trying to record as many lectures as I can throughout the semester, again, because people struggle to make it to campus because family members get sick, babysitters get sick, people have like financial problems. So I'm going to try to record as many of our lectures as I can so that if things happen, you'll be able to watch them, but try not to take advantage of it and make it to class because I like talking to you guys. And through talking with you, I learn more about what you guys need and what you might be missing. That being said, if you want a head start on what we'll be covering, I have this entire course on my YouTube channel via that link on Blackboard. It's actually, I have to fix that. 1 second. I accidentally clicked that one instead of this one. So this is my entire course from right when COVID started. So it's a little weird. I didn't know what I was doing. I had no idea how to teach online, but at least it covers all of the topics that we'll cover in class. It even has like an exam review. It has Python review. It covers everything that we will see this semester. Now, I was kind of hesitant to give you this because I want you to show up to class, but this is great. I don't know, it's great supplemental material for you, and I would feel bad if I didn't share it with you. So let me just go ahead and fix this link real fast. All right, so you have that now. Okay, so in the chat, I would like to know how many of you have programmed with Python. So just type yes if you have, no if you haven't. Nice, there's a bunch of no's. I like this because I think that Python is the best place to start programming. So I am a self-taught programmer. I never really took any programming courses in college. And the ones that I did, I really was horrible at. I think I took a total of 2. But I was really bad at it. I was more of a mathematician, and that's all I really cared about was the philosophy of mathematics and being that, right? But when I started teaching discrete math at Texas State University in 2017, like 99% of them were CS majors. And I remembered that when I was at Rice as a grad student, there were all these really cool algorithms that we could possibly cover in that class. So I just started trying to learn how to program so that my students could also do these things that I used to know about or that I've seen before. And I started with YouTube and found a bunch of great resources to slowly learn how to program. And Python was the best. I started with C++ because it's what I thought I needed to start with, which was horrible. I learned it, but like after the fact, going to Python, I realized like this is how you should start to learn the program. And I want to teach all of you how to program because I think that, I don't know, I have a unique perspective on it as a professor that was self-taught in that realm to kind of point you towards all of the things that you would need to learn even without me like around, right? So on that note, let me share my screen again. There's a link here under course content for Anaconda. So Anaconda is a suite of IDEs. So for those of you that haven't programmed before, an IDE is an integrated development environment. It's a way to interact with a programming language. Back in the day, people used to have to interact with programming languages with like simple text editors. But now we have an access to like visual GUIs, things that you can click on, things that kind of organize stuff for you, that give you proper error messages, and these are IDEs. And Anaconda is the best suite of IDEs for Python and another programming language called R. So if you go to Anaconda in products and individual edition, you can download Anaconda. It's free. And that's what you guys have to do after class today, because I will be showing you Python code throughout the semester so that at the end of the semester, you'll be able to program an algorithm with me, which is the whole goal for this course is to make you understand logic and flow and being precise and implementing it. And the way to implement those types of thoughts is with programming. So please go and download that. Now, for those of you that would like to see what it looks like, it's a little green symbol on my Mac. I'm opening it right now. So you install Anaconda and then you click on the little Anaconda Navigator and this thing will pop up. Okay. Now, this is the suite of IDEs. These are all ways to interact with programming. These are kind of maybe commercial ways. All of these are used in the industry, but I would say these are like commercial ways where you need like extra computing power. But for our purposes, we will just focus on these things called Jupyter Notebooks. So even for those of you that have programmed before, if you haven't programmed in Python, I doubt that you've ever seen something called a Jupyter Notebook. So I want to quickly show you how to open one up so that when you install Anaconda, before you get the textbook with the homework stuff and all that, I'd like you to play around with it. So you just click on this little guy here, and this will open up your web browser. Now this is hosted locally on your computer. So this is like my desktop computer right here. I have all my files here, or directories, depending on what you want to call them. And suppose I want to make a new file to store all the things that I'm going to do in this class. So maybe go to Documents, UHD Teaching, it's a mess, maybe over here. So this is where I want to be, UHD Teaching, and I'm going to come over here and say New Folder. Okay, so I'm going to open a new folder. Or not, yeah, I'm going to open a new folder, it's right here. I'm going to change the name by clicking right there in the little box. I'm going to rename it and say math_2305 spring 2022. Now notice I didn't put spaces. I think that for all of you programming type people, and especially you data science people that I'll see later in your undergraduate career, never put white spaces because white spaces are treated as characters and can mess with certain things when you're searching through your folders or directories on your computer using various languages. So the best practice is either to put a dash or an underscore. I prefer underscores, so that's why I'm using them here. So this is the name of the new folder that I'm making. There it is. So then I'm going to click on it and it's empty because I haven't put anything in here yet. Now, if I want to play around with Python, I can just go over here and select New, And then all of these things here are what are called kernels. There are ways to interact with a programming language inside of one of these Jupyter Notebook things. I have a bunch of different ways. I see someone in the chat. One second, let me answer that. Yes, I will post the Zoom recording for all of you. Okay, so don't worry about being behind. Just try to listen and follow along as you can. Okay. So I program primarily in Python and Julia. But I want to talk about Python. So I'm going to do new Python 3. And then I see this screen in front of me, right? Well, Jupyter Notebooks consist of code cells and other types of cells. All you need to focus on now is a code cell. Just so make sure if you're inside of one of these little guys, it says code. And you can press enter to make more space, or you can type code and press enter and type more code and press enter. So for example, everyone's first programming task is typically something called print hello world. So this is Python code now. You can see that the syntax lights up. So I call this thing called print, which is a function that will display this to the user. Now, if I want to run this cell, I hold shift and press enter and it runs. There's your first program in Python. And Jupyter Notebooks are ubiquitous throughout the data science community. If you're doing data science, you're more than likely dealing with some type of Jupyter Notebook for presentation purposes and for quick data visualization purposes. Of course, if you're working on like an app or a bigger project as like a backend or front-end developer, you would not use Jupyter Notebooks, you would use some other IDE, for example, Visual Studio Code. But for data science purposes, this is the primary way to interact with data and to play with data. I use it for all sorts of things. So for example, if I wanted to print some more stuff, like maybe do this, like just play around, print hello. I just pressed enter a few times to give myself some more space, print world, and maybe another one, print math 2305. So whatever I put inside of these quotation marks will be interpreted as what's called a string. And we're printing these strings to the user. So if I press shift enter, I see, oh, hello appeared, world appeared, and math 2305 appeared. That's not so bad, right? This is how easy it is to code in Python. You can also do like arithmetic operations. If you want to do like 1 + 1, press shift enter. You see the output 2. Okay, so this is a notebook way of interacting with Python. Now, if for whatever reason you're having trouble installing Anaconda and running these things, you can also go to something called Google Collab. So Google Collab is a web-based way to interact with Python programming that also manages all of the packages that you might ever see, which I forgot to mention earlier. When you install Anaconda, you're basically going to have access to all of the primary built-in Python packages, as well as Python. It will install everything for you that you'll probably ever need as an undergrad. So all of those packages will be installed. But if you want to run in a web browser, go to Google Colab, make an account, sign in, click on new notebook, and then you can have access to the same type of features. It just looks a little bit different. I'm printing the string, hello world. Okay, so it takes a second to run because it's like loading on the server or whatever. But these are just easy ways to interact with Python. For example, if I wanted to assign variables, so variables are typically lowercase characters like this that you assign to some values. I can assign this to like 10. I can make another variable, assign it to like 5. And then I can just say print, what if I want to print x + y? What can you imagine is going to appear on the screen? It'll be 15, right? 15. And then through this process, you can start learning things, right? And I plan on, again, even though this isn't a Python course, and you won't be graded necessarily on your Python programming, you won't, I can't require that. However, if you do pay attention and you follow the links and read the things I send you, you will have basically covered a lot of really useful Python. So just if you're curious, maybe I want to show you like some of the things you can do in Python really quickly, just because I want to. So for example, I could make a variable and I can call this variable statement or something. Like that. I can press Shift Enter, and now statement is storing that thing called a string. Right? It's that thing. You can enclose strings with double quotes or single quotes as long as you stay consistent. I wonder what happens if I look at, so if I wanted to learn about strings, this is how I went about doing it. Python string method. So objects in Python have methods. And if you know that and you search, you'll see these things. You'll find lists very quickly of methods. So for example, I see this one called capitalize. So it looks like I have my string and then I do dot, which is the typical notation used to get a method. And the method's called capitalize. Let's see what happens. So I come back over here and I do statement dot. Was there any arguments? In fact, I can just do this. There's nothing wrong with doing this. Anyone that's been a professional programmer ever knows that you copy and paste everything. There it goes. Let me see, Shift Enter. Oh, it made the H capital. Let me go back over here and see if there's anything else I can do. Maybe there's all kinds of stuff. Title. Title seems like something useful, right? Like maybe I want capital H, capital W, and I think that seems like title. So I go back over here to title. Press Shift Enter. Oh, now it's capital H, capital W. If I just take a guess and I do lower, oh, that works. If I just take a guess and do upper. So that's kind of nice, right? What about if I want to know, so like, what is did statement change? No, statement never changed. It was returning something new. What if I wanted to know if the letter H was in there? It is in there. And you can find out just by doing that. Is it in there? How about the letter capital W? No. But the letter lowercase w, yeah. So hopefully this was like a friendly introduction to just, it looks like a mess, right? And that's because we're just playing around with the ideas of Python. And I'm showing you that you shouldn't be afraid of it. You just know to type print and put in a string, it prints out the stuff. That's enough to get started, right? To do this in like a language like C or C++, you have to write a lot more, right? You don't just say print the thing. Assignment of variables, you don't have to worry about what type of thing that is. I wonder what happens if I do for time statement, because that's a statement is currently a string. Oh, it makes it happen 4 times, right? So this playful nature of it is why I began to like programming more and more, because I can play. And the logic and the control flow of writing programs is precisely what we will learn formally in discrete mathematics or discrete mathematical structures. In fact, the first 2.5 weeks we'll be doing nothing but logic and understanding things. Like if x is greater than y, like this is like an if statement. It's a Boolean idea, like if something, right? And what the first lesson that we'll have, like our first real lecture, will be about these things called propositions, which is a Boolean statement. It's either true or false. And it is. X is 10, y is 5. So yeah, it should print out something. Okay. So those of you that who Now, every semester, there are students that really dive into it, and there are students that kind of more or less don't care about learning this aspect along with all the math. But if you're curious to actually dive in, I'm going to provide you with every link that you'll ever need to see to learn throughout the semester. And you would be amazed at how far I've seen students go in discrete math. Like I've had students literally go on to take Python 1 and 2 and say that we covered more in discrete math, or they were exposed to more in discrete math than those two courses put together. Just so long as you decide that you want to watch and follow along with the stuff. This first one here is someone who taught me. All right, so actually I should rename this. Right. And if you like, all you have to do really is just like ignore the first one because you installed Anaconda. Just pull this guy up. Ignore all the ads. And then just watch what he's typing. And literally, this is what I used to do in the morning. You probably can't see that. I need to get bigger. And then I would grab my stuff and I'd pull it over here. And then, so here it goes. Where is it? There. And I would just play these and I would follow along. I'd say, what's he doing? Pause, do it over here. So I see that he has message equals that and then print that. So I'd come over here and just do, I would type it just like he did. Just see what happens. And then when he runs it, it'll pop up for him. And I don't know. It's a really easy way to learn. Okay. So I'm going to hopefully hear back from Zybooks about your textbook, your textbook information to go ahead and start working on the book. But in the meantime, install Anaconda. If you want to get started on the lectures, I provided the link to that playlist from 2020 for this same course. Or if you want to start like trying to play around with Python, go look at that Corey Schaefer playlist, pull up a Jupyter notebook and just program next to it and see if you can learn anything. Okay. So I suppose, honestly, that's it for today. Just go install Anaconda, play around with it with Jupyter notebooks, watch those videos, and then be looking for a link to, not a link, a list of criteria that you need to enter in at Zybooks to get the book. Right. Does anyone have any specific questions for me? Would you like to see, like, okay, in the chat, how many of you are interested in seeing like something kind of what my students thought was pretty cool last semester? You don't have to learn it. It's just a Python thing that you can see how easy it is to do something interesting. Like in the chat, if you would like to see that, I'll show you. Okay, so overwhelmingly yes. All right, I have to preface this. This is not like discrete math. This is just me showing you that Python's kind of cool and you can do some stuff. I'm trying to motivate you to actually watch the videos that I'm going to send you. All right, got to share my screen again. Now, I was not planning on doing this, so I apologize if I forget the syntax for everything. I've been spending a lot of time programming in Julia lately, which is very similar to Python, so I get the syntax messed up. All right, so y'all ready? All right, well, this is looking like a mess right now, so I'm going to get rid of these cells, and I can do that by clicking on a cell and then just doing this. Just to get rid of the cells I don't want. Okay, so My students, for whatever reason, last semester were really enjoying this kind of machine learning financial type of stuff I was getting into. So that's what I'll show you that you can do relatively easy. So in Python, you would import libraries, and there's a few specific ones that I'm going to import. This does not come with Anaconda, but if you want it, you do this. If you run this exact cell, you will have this package. Currently, you probably don't have this package, right? All right, so I'm gonna get rid of that. All right, so I'm importing all of the things in that library as this alias. So this is how I'm gonna access it. Now, these other ones you do have. So pandas is kind of standard for every data scientist. So is NumPy. So pandas is like tabular data. It's a package for tabular data. NumPy is for doing like linear algebra, which all of you are taking linear algebra and you really need to pay attention to. And then if I want to visualize things, I'm importing this library as that alias. Okay, so those are all just libraries that I'm looking at. And I'm going to use this data reader thing to get me some information on Yahoo Finance, because everyone is losing all their money in crypto right now. So let's look at a ticker here. So this is the one, maybe ETH, it's probably my favorite. So I can access this by doing, I'll call it like data is equal to web, which is this guy right here, dot. So this is a function that's inside of here. So if you ever lost and you don't know what's happening, you can always go and search, like just search the package and the function, and you'll probably get the arguments that you'll need. So I'm pretty sure I need to pass this, the ticker of my guy here. So this one, that's the ticker, the symbol. So, and it is ETH-USD. Where am I getting this data from? Yahoo. And my start date, I'll say, is equal to 2019. I'll say 2020, January 1st. Hopefully that works. So now I just want to look at the top of my data. So this is a pandas data frame. So what have I just gotten here? Well, actually, I'll just show you the full thing. This is the list of all high, low, open, close, volume, adjusted close prices or values for this Ethereum cryptocurrency from 2020 to today. And then if I just want to look at the thing, I can do use my plot package there. So plot.figure, make a nice big one, and set my fig size to be kind of big for everyone to see, like maybe 12 by 10. And then I'm going to plot stuff. I want to plot data, and I just want to look at maybe the closing prices or something. So to access that, I use this dot notation, which if you start to study Python, you realize that's always how you do things when you're if you're accessing attributes of something, an object, you dot in the name of it. So close is a column of this tabular data, and that's how I'm going to access it. And then I think this is the notation. I don't know, I like magenta. So you can see that this is the price data over that amount of time. And it was done really quickly. I'd plot it, I read it in, I didn't have to do that. And now this is what appears, which is kind of cool. So and then you can start doing like trend lines and stuff like this, and start like, it's called like regression, which is something you do in data science all the time, is regressing values, trying to fit a line to certain data. I can try to do prediction types of things, all sorts of interesting stuff. And it's great because Python makes it easy. If you understand that you have an object and you always access a function on that object with the dot, and you look up the information about the function, you can start using it. And that's why it's so prevalent in industry now. because yes, you could do this in a more efficient and like optimized way with something like C or C++, but by the time you get the code running to do the thing, some other company has already beat you to it by prototyping it quickly in Python. And then after it's been prototyped quickly and like shows some like sign of working, then it goes to after developers to drop it down to C or C++ to really speed it up if you need to. So prototyping in Python is kind of a thing, but Python's fast enough on its own that really you can just use it. And I don't know, it's super easy to change here. Like if I want to look at PPC, just press Shift Enter a bunch of times. This is the other one. I don't know. Maybe that's interesting, maybe it's not. I actually prefer looking at other data. Like for example, what is that data set? Where does it come from? I've recently found a new data set called penguins. In this package here, this is, I also am a professor at Rice University. I teach one course over there every semester called Data Science and Machine Learning. And last semester, the students kept on turning in, I'll call this penguins or whatever. So basically, I just loaded in a library which happened to have this penguins thing, and it's basically a bunch of measurements on penguins. And you can like, you can plot this stuff. So like, maybe this will work. I see that there's missing data, which is often the case in real world data. Penguins. Actually, I'll just pull up. I don't want to have to code it too fast and bore you too much. If you're really interested in looking at the penguins, which I like them. I've recently been looking at these types of things. Where are they? Penguins, that picture right there. And you can, I do this in Julia, but like, I just wanted to show you what the plots can look like because it's basically the same in Python. Where is it? I can't find it fast. I'm gonna have to program it, whatever. Sorry about that. I'm accessing, I'm gonna scatter this versus the other, like bill length versus bill depth. I thought I could have done that fast, but it didn't work out. The column names exactly. And then let's just look at this for a second. So there's some type of pattern hidden in here, right? Like if I look back at my tabular stuff, I see that there's different types of species, right? These Adelie, Gentoo. I think there's another one. Maybe I can look at the unique ones by converting it to a set, which we'll learn all about sets this semester. Lowercase set. So these are the 3 different types. So maybe if I just do this, Adelie as a capital A. I think that's the syntax. And then Adelie. So I'm just looking at the Adelie penguins. Did I spell it wrong? I guess I'll take the time to do this. Well, I don't want to overbear you with things, but basically, there's just like so many different ways to look at the data. I'll like if you pay attention to my YouTube channel, you'll see that for all of my classes, I'm making videos, and for my machine learning class, I'll be doing one on the penguins if you want to see them. I just kind of like the way they look. Yeah, these guys. And it's just like measurements of these guys, and you want to somehow predict which species is which based off of measurements of their bills and their flippers and stuff like that. Data science-y type of stuff, which even though there's a lot of CS majors in here, all of you should be aware of data science and should maybe, like, I'm not telling you to major in it, but going forward, like as time goes on, like data is becoming more and more prevalent and understanding it is important. So yeah, that's super important. Well, I don't know. I showed you some messy code really fast. Hopefully it shows you that it's easy to play with and you just kind of have to watch the stuff I send you. And a lot of these concepts will also be covered in mathematical terms during lectures. So I guess that's it. Thank you for listening. If you would like to actually know more about our data science, I prefer Jupyter. I just saw that in the chat. I prefer Jupyter for like quick data science types of things. Whereas if I'm doing like serious types of coding, I use VS Code, which is an IDE from Microsoft that runs on any platform. Like I use Mac and Linux only pretty much, but VS Code is my main IDE of choice. And for a lot of data scientists. But yeah, so I know that many of you might be new to UHD and be like have questions, so just feel free to email me, and my email is on the syllabus. Also, some of you might not know that we do have a data science bachelor's degree. If you're interested in hearing more about that, yes, you can access that data if you pass in a website other than Yahoo. So you just have to look at the documentation to see what that is. I'm answering Gabriel in the chat. But yeah, if you did not know that there was a data science bachelor's degree and you would like to know more, just email me, ask any questions you want. I find that a lot of computer scientists take interest in the field after they see the things that you can do, which there's like two sides to this. If you major in data science over CS, you miss out on things like operating systems or assembly, which I think those are like academically interesting. I find those topics interesting, and like C is one of my favorite, like not my favorite, but I respect like the history of the C programming language as far as like starting everything out. And I would have liked to see that as an undergrad. But on the other hand, if you do a data science bachelor's degree, you get to look at a lot of very applied problems, and you get to work with like image data, like machine learning, statistical analysis of things. So there's just a trade-off. It just depends on what your personality is, right? So I'm not trying to discourage you from majoring in CS, but if you have questions about majoring in data science while it's still early, and many of your courses transfer from one degree to the other, or they fill parts in, just ask me. I was a part of the committee that designed the degree, so I know a lot about all those details. So feel free to ask me. And yeah, I look forward to the semester, and I think that we'll all have a good time. And hopefully I'll be walking soon without a broken leg. Maybe next week or the week after, I'll be in something, a scooter or boot, where I can come to class and lecture in person. But for now, this week, Zoom, probably Tuesday Zoom, and then we'll see. Yeah, Thursday will be online as well. All right, well, I look forward to hearing from you. Yeah, I'll see you guys on Thursday.